Good day everyone. Today we're going to discuss thermal properties of matter. At the end of this video, you will learn how to relate the pressure, volume, and temperature of a gas. Also, you will learn how the pressure and temperature of gas are related to the kinetic energy of its molecules. Next is how the heat capacities of a gas reveal whether its molecules are rotating or vibrating. And lastly is how the speed of molecules are distributed in a gas. Okay, the kitchen is a great place to learn about how the properties of matter depend on temperature. Say when you're frying a pan, how does the speed of the molecules in the air above this pan compare with that of the ones in the rest of the kitchen? How do the atoms of a gas determine its temperature and pressure? In this topic or in this lecture, we'll see how the microscopic properties determine its microscopic properties. So basically, kaning duha, ang microscopic ug ang macroscopic ay related na silang duha. So later, ma-discuss nato ni unsa ang relationship aning mga macroscopic properties and these microscopic properties. By the way, these are the macroscopic properties. We have pressure, volume, temperature, and mass of the substance or amount of the substance. And for the microscopic properties natay, masses, speed, kinetic energies, momenta of individual molecules. So basically, at the end of this video, we will relate macroscopic properties like pressure, temperature to its microscopic properties like kinetic energy, speeds, and so on. So, naay usa ka equation or naay isa ka model that relate kaning microscopic and microscopic. So, we will discuss that later. Okay? So, we will define first state variables. State variables are these: pressure, volume, temperature, and amount of substance. They describe the state of the substance. So, muna ang mga state variables. We have P for pressure, V for volume, N for amount of substance, and T for temperature. Okay? And then, we also have the so-called equation of state. So, if we have state variables, relating this or putting these state variables into an equation, we have this equation of state. And it is defined as a thermodynamic equation relating state variables which describe the state of matter under a given set of physical conditions. So, usa ni siya ka equation na nag-relate aning mga macroscopic properties or microscopic properties. Say pressure, volume, temperature, internal energy, and so on. Examples of equation of state that we will discuss is we have this ideal gas equation and the van der Waals equation. So for ideal gas is simply equal to this equation, PV equals nRT, where P is the pressure in terms of pascals or ATM or atmospheric pressure, V is the volume, N is the amount of substance, or we also call this one as number of moles, R is the gas constant which is equal to 8.314 joule per mole Kelvin, and T is the temperature. So this equation is basically dealing with the relationship between the pressure, the volume, and the temperature, which are the macroscopic properties of a substance. So it is equal to PV equals nRT. For example, using this ideal gas equation, find the volume of a container that holds exactly 1 mole of an ideal gas at STP. So what do you mean by STP? It is standard temperature and pressure. Meaning kung may kung STP, automatic the temperature is at 0 degrees Celsius, or we convert it to Kelvin, it is equal to 273.15 Kelvin. So that is my temperature at STP, and my pressure is equal to 1 atm. Okay, it is equal to 1 atm, which is equal to 1.013 times 10 to the 5 pascals. Take note of this. The pressure at STP is 1 atmospheric pressure, which is equal to, in terms of pascal, it is equal to 1.013 times 10 to the 5. So that is around 100,000 pascals. So question is, calculate the volume. Using ideal gas equation, calculate the volume. This is very simple. You will use the equation PV equals nRT, and ang atuang kuhaon is the volume of the container that holds exactly 1 mole. 1 mole is, that is your N. N is equal to 1 mole of an ideal gas at temperature nga 273 Kelvin and pressure nga 1 atmospheric pressure or 1.013 times 10 to the 5. Take note, ang SI unit sa pressure is Pascal. So you need to convert ATM, atmospheric pressure, into Pascals. Okay? So substituting now, the N is 1 mole, R is constant, temperature is 273, pressure is 1.013 times 10 to the 5 Pascal. Then the volume of a container that holds exactly 1 mole of an ideal gas is equal to 0.0224 meter cube. And if you convert that to liters, that is equal to 22.4 liters. Take note, 1 liter is equal to 10 to the minus 3 meter cube. Okay, so that is why gimove lang mo sa katulog pa left. Because 1 liter is 10 to the minus 3 meter cube. So, ingana kada ko ang volume nga sa container nga mag-hold sa 1 mole of an ideal gas. Okay? Another example. So we have this volume, a 20-liter tank contains this mass 10 to the minus 4 kilograms of helium at temperature nga 18 degrees Celsius. You have to take note that ang temperature, the SI unit of temperature is in Kelvin, so kinahanap po namin na siya i-convert to Kelvin. Okay. The molar mass of helium, this is constant, for helium that is 4 grams per mole. Okay. Question is, how many moles of helium are in the tank? Next, what is the pressure in the tank in pascals and in atmospheres? Okay. So, to calculate first, letter A, to calculate the moles of helium, we have to take note of this equation. Note that the total mass of this gas is equal to the number of moles times this capital letter M, where capital letter M is our molar mass. Take note, capital letter M is our molar mass and the small letter m is the mass of this ideal gas. So to calculate the moles of helium, ang atong kuhaon lang is only the N. So N is equal to the total mass of this helium over the molar mass M, and they are given ang M nga total 4.86 and the molar mass is 4 grams converted to kilograms per mole, natay 0.004 kilogram per mole. So therefore, how many moles of helium? Then the answer is 0.122 mole. So ang naa sa kaninga tank nga number of moles is equal to 0.122 moles. Okay. For letter B, calculate the pressure using ideal gas equation. The pressure is equal to nRT over V. Given na si N, no? Muna ito nakuha sa letter A, which is equal to 0.122. R is 8.314. Temperature is 18 plus 273. You need to convert this temperature to Kelvin. And the volume is 20 liters converted to meter cube. Take note, the SI unit of volume is in meter cube. So, kinahanglan i-convert na ko ng liters into meter cube. And we know that 1 liter is equal to 10 to the minus 3 meter cube. Input na to ang given, we have this N, this is R, constant, and this is temperature in terms of Kelvin, and divided by the volume, 0.02 meter cube. 20 liters is equal to 0.02 meter cube. So therefore, pressure is equal to 14,766 pascals, or if you convert this to ATM or atmospheric pressure, that is 0.146 ATM. So sa ano ni, divide lang nimo ng 14,766 to 1.013 times 10 to the 5 pascals, or 1.013 times 10 to the 5, makuha nimo ang atmospheric pressure na 0.146. So this is now the pressure in the tank using ideal gas equation. So simple lang, no? Simple lang ang ideal gas. It is equal to PV equals nRT. Okay? Okay, next. Another equation of state, example of equation of state is we have this van der Waals equation. So, sa ideal gas, this is equal to PV equals nRT. Sa ideal gas, wala nila i-consider ang unsa kadako or unsa ang size sa imong molecule. So, wala nila i-consider ang volume sa imong molecule. Also, wala po nila i-consider ang intermolecular forces between molecules. That is why natay gitawag nga van der Waals equation para i-add ning duha ka term. The term for volume of molecules and the term for the attractive forces between these molecules. So basically, mas realistic siya nga model compared to the ideal gas equation. Kaya namay mas realistic siya kaya gi-appealan man niya of course nagi volume ang molecules and also naapoy mga forces, intermolecular forces between them. Okay? So this is van der Waals. Nakoy gidungag nga duha ka term and ang kanang term is kaning this one, an square over v square and this n times b. Okay? Where a and b are constants. So see a, this a, take note a and b are constants. And A is a constant that depends on the attractive intermolecular forces. So basically, kaning nga term is muni ang i-add nga term for the attractive forces, the intermolecular forces between molecules. Okay? So kani muni ang nag-add sa imuhang for attractive forces between molecules. And B is a constant that represents the volume of a mole of molecules. So basically, kani nga term is muni ang gi-add nga term for the volume of molecules. So this is now my van der Waals equation. Take note, when A and B are constants, are zeros, or rather, when A and B are zeros, then this will reduce to ideal gas equation. So, van der Waals, gidungagan lang nimo og duha ka term. Ako, A n square over V square for the attractive forces and NB for the volume of the molecule. So this is basically the van der Waals equation. Say for example, using van der Waals equation, okay, for example, we have this carbon dioxide gas, CO2. The constants are A is equal to, take note for carbon dioxide, this is for carbon dioxide. The constants are A is 0.364 joule meter cube per mole square and B is 4.27 times 10 to the 5. Question: if 1 mole, meaning N is equal to 1, of carbon dioxide gas at temperature nga 350, okay, if 1 mole of carbon dioxide gas, okay, at temperature of 350 Kelvin is confined to a volume of 400 centimeter cube. So kinahanglan po nimo na siya i-convert to meter cube. 400 centimeter cube. So na kay volume of 400 centimeter cube. Question is find the pressure of the gas using two equations. First is ideal gas equation and the second one is the van der Waals equation. So lantaon na to, pila ang pressure kung mogamit ko og ideal gas o kung mogamit ko og van der Waals equation. Which equation gives a lower pressure? So lahi man sila og pressure, makuha na to later. Lahi ang pressure if you use ideal gas and we will use van der Waals equation. Kinsa ang mohatag sa gamay nga pressure? Question is why. Okay? First, so the solution is this. Nakoy for the ideal gas equation, this is equal to PV equals nRT. And for van der Waals equation, nakoy nga ni na equation. Okay? Using first ideal gas. So kung magamit ko ideal gas, makuha na ko ang pressure. Pressure is equal to this. N is 1 mole, nakoy 1 mole na given. R is 8.314, temperature is 350, and the volume is 0.0004 meter cube. So, sayon ram na sa i-convert, 400 centimeter cube is equal to this in meter cube. So, pressure is equal to around 71.8 atmospheric pressure using ideal gas equation. Okay? Using ideal gas equation. Now, using van der Waals equation, we have this equation. Calculate the pressure. Input lang nimo tanong given, no? P plus kani, this is my A. A is 0.364 N square over V nga 0.004 times volume minus N times, this is my B, equals 1 mole times R times temperature na 350. Simplify this, you will get this. Transpose, you will get the pressure equal to 57.9 atmospheric pressure. So notice, dako ka siya og diferensya, no? For van der Waals equation, that is 57, my pressure is 57.9. For ideal gas equation, ako is 71.8. So which equation gives a lower pressure? Unsa nga equation? Na ako ay van der Waals equation. Mas gamay ang pressure kaysa ideal gas. Why? Because mo-reduce ang pressure because of the intermolecular forces between molecules. So kung naay mga attractive force between molecules ang mahitabo, instead nga kusog ang pag-collide or kusog ang pagbangga sa mga molecules sa container sa imuhang tank, magkahinay ang imuhang collision, ang force magkahinay kay giapilan man nimo siya og kaning attractive forces between molecules. So magkahinay ang force, meaning magka-reduce ang pressure. So mo reduce ang pressure. So that is why gamay ang pressure sa imuhang using van der Waals compared to ideal gas equation. Notice dako kay siya og diferensya. Okay? And take note, the more realistic model is this van der Waals equation. So these are the equation of state, the ideal gas and the van der Waals equation. Okay, PV diagrams, basically ang PV diagrams kay graph lang siya between pressure in vertical axis and volume in horizontal axis. So in this graph, nako upat ka curve, we call this one as constant temperature curve, or some term isotherm curves, meaning sa isotherm kay constant yung temperature. Okay, so this for each curve, PV is constant and it is directly proportional to temperature. Okay, so this is my PV diagram. So we will makita nato ni siya kasagara sa next na chapter, the laws of thermodynamics. Okay, let's now go to molecular properties of matter. So basically, in molecular properties of matter, ang ato lang kuhaon dyan is we are looking at the relationship of bulk behavior to molecular structure. So dili na ta magsugod og relate sa katong mga macroscopic properties ug ang microscopic properties. So unsay relationship sa pressure, volume, temperature ug sa katong mga kinetic energies, momenta of individual molecules. So what is the relationship between macroscopic and microscopic properties? We also have these intermolecular forces of molecules, and we will define Avogadro's number later. So for molecules and intermolecular forces, we have to take note that molecules are always in motion. Also, in gases, the molecules move nearly independently. In liquids and solids, they are held together by intermolecular forces. So that is why rigid ang imong solid, because naay some force, some intermolecular forces na nag-bind sa ila. Okay? Sa gas, mas independent ang mga molecules. So, kusog ang ilang yes. The force between molecules in a gas varies with the distance r between molecules. If I have two molecules, for example, kani nakuha ka molecule and it is separated with some separation distance r, then the force between them varies with the distance r between molecules. So, depende sa separation distance ang ilang force. Okay? Also, its potential energy. It is also dependent on separation distance r. To illustrate the relationship between force, potential energy to separation distance r, we have this graph. We have these two graphs. The red one is the relationship between the force and the separation distance r, and the potential energy is represented by this blue one. For this red one, notice when your separation distance r is less than this r naught, take note this r naught is at this point, the force, if you look at this force is positive. It means that the force between molecules is repulsive. So at this region, when the separation distance is less than the R naught, then the force between molecules is repulsive. But when R is greater than R naught, your force is negative, then the force between molecules is attractive. So we have this graph for force and separation distance R. For potential energy, we have this. At R is equal to R naught, dira mahitabo ang force between molecules equal to 0, and ang potential energy of the two molecules is very small, or it is minimum. It is a minimum na value. So nadiri ang when R is equal to R naught. So take note at this point, walay force niya lang duha sa duha ka molecules is R is equal to R naught. Okay? We also call this one as potential well. So we also call this one as potential well. Now, molecules move under kinetic energies usually increase with temperature. So basically, we will relate now some microscopic property like kinetic energy to a macroscopic property like temperature. So the kinetic energy and temperature are interrelated. So na relationship ani duha. Muna karon. Kung gamay ang temperature at low temperature, the kinetic energy is less than the depth of the potential well. So meaning kung gamay mo temperature, gamay pud mo ang kinetic energy. Okay? Then the molecules then condense into liquid or solid phase. So magdepende di ay ang phase of matter, magdepende siya sa kinetic energy of molecules, ug ang kinetic energy kay magdepende pud sa temperature. So notice kung ang water, kung i-reduce nimo ang temperature sa water from liquid, mahimo siyang solid. It's because magkahinay man ang energy sa molecules sa imuhang water molecules, mugamay ang energy, so mahimo siyang solid phase of matter. Okay? Di naman kay sa kalihok, di na kaayo kalihok ang molecules, ang water molecules, because at very low temperature or at 0 degrees Celsius. But when the temperature is higher, then the average kinetic energy becomes larger than the depth of the potential well. Then the molecule can escape the intermolecular force and become free to move independently as in the gaseous phase of matter. So since gamay kayo ang attractive force sa imuhang molecules, so that is why maka-escape siya ato nga force at higher temperature. So ang point lang ni is na relationship imong kinetic energy ug imong temperature and also the phase of matter. Okay, so next is we have this mole and Avogadro's number. 1 mole, take note, of a substance contains Avogadro's number denoted by Na of molecules, and that is constant, which is equal to 6.022 times 10 to the 23 molecules per mole. And the molar mass M is the mass of 1 mole equal to this. M can be written as, in terms of Avogadro's number, M is equal to the Avogadro's number times the mass of a molecule of a substance. For example, find the mass of a single hydrogen atom and of a single oxygen molecule. This is very simple. To solve for the mass of a single hydrogen, we will use this equation. M is equal to NaM. Okay? So, using that equation, makuha nato nga si mass of a single hydrogen atom is equal to the molar mass of this hydrogen, single hydrogen. And given na siya, no? Given na siya. It is equal to 1.008 gram per mole over the Avogadro's number equal to this. So you will get the mass of a single hydrogen atom equal to 1.67 times 10 to the minus 24. For a single oxygen molecule, take note, for the oxygen, the atomic mass is 16 gram per mole. But take note, oxygen gas has two oxygen contains a 2 atom of oxygen. Then the molar mass is i-times 2 lang nimo na atomic mass sa imong oxygen, which is equal to 32 gram per mole. Then the mass is equal to, using that equation for molar mass, na ako'y molar mass over the Avogadro's number, you will get the mass of your single oxygen molecule. Take note, oxygen molecule is contain siya og duha ka oxygen. So that is why nakoy O2. O2 is oxygen gas. Okay?